Now I'll record. Okay, cool. So, that took a while. So, the idea is that we should be able to do the observation for this one. However, we need to start considering what it means for something to be in excess or limiting at the end of the reaction. Okay? So, if we do this, we're going to go write out the equation. So, copper 2 chloride, CuCl2, aqueous solution, added to sodium carbonate, Na2CO3, aqueous solution, to form. Hopefully, you guys will be able to get this at this speed at some point, but that's okay for now. We're just going to do it like this, and I have that there as a balanced equation. Okay? So we'll be able to do that at some point to write out the full equation. Then I can write out the ionic equation. Okay? I should recognize that I only have this as my only thing that changed state, so therefore I can just quickly write, okay, here are my copper ions, here are my carbonate ions, and I form copper carbonate solid. Right? The fast way to do the ionic equation is to just recognize what does change state and then just not write that thing in. Okay? So, observations. Now, normally we would say, okay, we have this thing here, we would have a blue solution. What's causing it to be blue? It's the copper ions. Okay, copper ions is added to, then I have this solution here, which is the colorless solution. Colorless solution, so that's the two reactants to form then I look at this substance here, the copper carbonate. What color is the copper carbonate? Don't say red. Sorry? Green. A green what? A green solid or a precipitate, that's fine. And then I would say this one here and a colorless solution. However, so that would be, saying I have talked about the products and the reactants. However, what I haven't done, I haven't taken into account that this is in excess. That's in excess. If that's in excess, what else is going to be there at the end of the reaction? At the end of the reaction, there's also going to be copper 2+ ions and chloride ions. Does that make sense? Because it's in excess. Now, I don't actually write this in the equation, in the ionic equation. I don't write that in the ionic equation. I'm just writing that out just to show you the idea. Okay? So, those copper 2+ ions are present. So therefore, I have to talk about all of these being present in the solution at the end, because I have something that's in excess there. So, if that's what's there at the end in the solution, which part here, the blue, the green, the red, or the yellow is incorrect? The yellow. I am no longer making a colorless solution. What should that be? A blue solution. Now, is it the same blue solution as it was at the beginning? Is it the same blue solution as it was at the beginning? Will it be the same color? No. Why will it be paler? Because? Have a think. Because? What gives it the blue color? What? Yeah, the ions give it the blue color, right? So will there be more or less of the blue ions? Why will there be less? Because some of them have been used up in the green solid or in the copper carbonate. Happy with that idea? So you have less of them, so it's not a blue solution at the end. You can say a less intense blue solution, or you can call it a paler solution.
Do you have to say that?
Why are you not working, pencil? You stupid. So you can choose either less intense or paler blue solution. Both of those are acceptable. Sorry, what?
So do you have to say that?
Yes, right? You have to say that it is different from the original blue solution. Okay? So that would be the idea behind saying one is an excess and one is a thing. Now, this entire observation would be different if the other substance is in excess. So if I said that the sodium carbonate is in excess, the reaction would be the same. The reaction would be the same. Does that make sense? However, what would be different is that there would be none of these copper and chloride ions over there. And so, instead, it would be going back to a completely colorless solution again. If there was excess sodium carbonate. Happy with that idea? If there's excess sodium carbonate, there is no copper ions left in solution, and so therefore it goes back to being a colorless solution like we wrote before. Okay? Happy with those ideas? Let's go through one more example. Okay, so let's do nickel to chloride added to silver 1 sulfate. Is silver 1 sulfate soluble? I think it is. Go check. Is silver sulfate soluble? Slightly soluble? Okay, so slightly soluble then requires you to look at the concentration. Okay? So, I think slightly soluble is less than 0.1 mole per liter. So I'm not going to pick that one here. Let's go pick something different then. Let's do something hydroxide. Let's do potassium hydroxide solution. Okay, and then I'm going to say it's excess potassium hydroxide solution. Okay, so let's go through and work out the different thingamabobs, right? What have we got? Nickel 2 chloride. What's the formula for nickel 2 chloride? NiCl2 aqueous plus excess potassium hydroxide. What's the formula for potassium hydroxide? KOH aqueous goes to KCl plus Ni bracket OH bracket 2. KCl, is that going to be solid or aqueous? Aqueous. And nickel hydroxide is? No idea. Correct. Ni. What is it going to be? Solid or aqueous? Solid. Okay, so that one is the reaction. What would be the ionic equation? Nickel plus hydroxide, just like that. Nickel what, sorry? Nickel 2, aqueous. Hydroxide minus aqueous goes to NiOH, just like that. What's wrong with that? What's wrong with that? Brackets where? Here? You're going to be more specific then. Okay, so brackets 2, is that it? Balance the equation there. Okay, so that one balanced there, over there as well. All right, okay, cool. So that's the reaction. We have to start talking about the stuff here. So what color is this nickel chloride solution? Nickel chloride is what? Sorry? Green solution. Is added to colorless solution to form, what's that? White, incorrect. Colorless. Colorless what? And? Not a white solid. What color is nickel hydroxide? Green solid.
Does it matter what order?
No. Right. Nickel hydroxide is green. Are we happy with that? So remember, you look at the top box. Nickel hydroxide is not there. So therefore, you look at the bottom boxes and you say the nickel ion is there. So it's green. So the solid will take the color of the component ions. Okay, cool. So then we start to think about excess and limiting. So I have excess potassium hydroxide. So what else will be in the solution at the end? What else will be in the solution at the end? Well, yeah, what? What is going to be there? K plus and NO3 negative. Where did you get this nitrate from? OH negative. And, well, if you really wanted to be precise, it will also be Cl minus as well, as a spectator ion anyway. Right? So those would be all of the ions that are present as spectator ions. Well, not really spectator ions for OH because it was used up, but not all used up. So the one that wasn't all used up, the OH, was what color? Colorless, so therefore it stays as a colorless solution, right? However, if I change this excess to be the other thing, let's now just say it's excess nickel. These aren't going to be the ions that are present. What ions are going to be present? What, sorry? Nickel 2 plus ions are going to be present still, and chloride ions and potassium ions. Those will all be present. Potassium is still there because it's a spectator ion. It was there always, right? So now this ion here is green, so therefore that changes which part? The green colorless solution. How can it be green and colorless at the same time, sir? I meant this green colored text. So this will be a green solution. Is that it? Nope, the green solid's still there. What else? Now, do you say pale green? No, paler, because pale green is used to describe a different colored ion. Does that make sense? So you can't say pale green, it has to be paler or less intense. Okay? Right, that's that.